Yes or no? All of you can see the screen, na? I hope so. Just let me know if you are not able to see the screen, and write the topic. Chemical properties. We have just studied, we saw, no? I mean, the last class we have seen hot copper, primary, secondary, tertiary. Yeah, fine. Now we are going to look at the reactions of phenol, chemical properties of phenol. Please write first of all. Tell me.
So I can just put that oxidation, chloration, that reaction.
Yeah, tell me.
So oxidation, chloration.
Sorry?
So that method of preparation in oxidation, chloration.
Say it properly first of all. ये क्या बात है? Oxidation बोल रहे हैं, फिर method क्या बोल रहे हैं आप? साफ बात कीजिए भाई.
Hydroboration, sir. Hydroboration, oxidation.
Hydroboration, oxidation. साफ बात कीजिए ना. That will be the first method of preparation, no? Yes, tell me.
Yes, sir. 1 minute.
Fahad, I can see you have sent me 2 photos. I understand the which one? I understand you have marked 2 questions. So okay, I will do that. And I don't understand with the first one, which question you are trying to ask me. In the in-text questions, so 11.5, I can understand what is your question, but I don't understand for the other picture. What is the question?
Done, sir.
Done. Okay. So first you have asked a few questions. Huh? First of all, please see. These are these are from the method of preparation itself. Okay. So first question is, this is in-text question 11.5. A double bond here, and this is attached with CH2, bonded with C double bond O, which is further bonded with OCH3. And we are using a reagent that is NaBH4. 7 and 8, which are fine. So here we have 2 carbonyl carbons. Here we have the ketone, and here we have the ester. So ester requires lithium aluminium hydride. So that will not be reduced to alcohol, but the ketone will be reduced to 2-degree alcohol. Okay, so OH, CH2C, double bond O, and OCH3 as it is. Okay, that will be the product here. 11.5, I think this is the second one. And for the third one, we have 1, 2, 3, 4 carbon atoms, CHO, and here we have a CH3. And in the presence of NaBH4, aldehyde will get converted to alcohol. So I will have 1, 2, 3, 4 carbon atoms, this CH3 as it is, and this carbon atom will get OH. Predict the major product. See, you have to you have to do something. No, you cannot just ask me like this 1-methyl cyclohexanol and sir, can you please make the product? You can, you can just Google this, you will get the answer if you want the answer. Okay, if you're asking me any question, show me some work. Like then only I can understand now where you are having problem. If you can't make 1-methyl cyclohexanol, then the problem is not in the alcohol chapter. The problem is in IUPAC nomenclature. Okay, so at least make the structure, show whatever you have done. Fine. Otherwise, guides are available, like all the complete NCERT solutions are available. You can look there. If you want to understand what problem you are facing, you have to tell me. You'll send after the class. Okay. You send me after the class, whatever you have done. 8 one orthogonal more acidic than phenol. Draw the structure of the corresponding phenoxide ions. Now, again, in this case, you just need to, I mean, this is manual labor, nothing else. NCERT just needs you to know these things. You have OH and you have, let us suppose, NO2 here. Double bond O and single bond O here, right? Now, when it is going to get into phenoxide ion, double bond, double bond, double bond, here you will get O negative, and here you'll have nitrogen with double bond O and a single bond O here like this. Now, the resonating structure will be, first of all, it will go here. Then this particular will go here, this particular electron will go here, and you will get double bond O, nitrogen with double bond O and a single bond O here. This getting a negative charge and double bond, double bond. Now this negative charge will go here. This oxygen, this will go onto this particular oxygen atom. Okay. Then you can also flip this sign. This negative charge can go here, and this double bond can move here. So there are two cases you can make, and all the resonating structures are fine. Other thing is that they are not going to ask this in the board examination. That you can I can write it down. In text question 11.7 will not come in boards. बड़ा risk है इसमें लिखने के लिए, लेकिन फिर भी हम लिख देते हैं because CBSE does not generally ask about these type of questions, है ना? They will ask you why type of question, what is happening here. They are not going to really ask like draw that manual labor वाला काम generally CBSE 12th के exams में नहीं करता है, ठीक है? So this is just making of resonating structures. Okay. Someone send me something. No. अच्छा. चलिए see here guys. Just a second. Give me a second, guys. I need to just send them the topic of this class. Okay, so today's topic is chemical properties of phenols. Now, first reaction, please write. Reaction with zinc dust. So a very easy reaction, and this is something important reaction also because here phenol directly gets converted to benzene ring. So you may see this in organic conversions plus Zn. It is going to give you benzene. Like next. Even this reaction, it sometimes comes in the board examination. That is the oxidation of phenol. Is right? Oxidation of phenol. Plus, you can use reagents such as Na2Cr2O7 or also K2Cr2O7 in the presence of acid. So, please write Na2Cr2O7 in the presence of H2SO4. You will get benzoquinone. double bond O here, double bond O here, and double bond here and here. This is known as benzoquinone. After this, please write electrophilic aromatic substitution. In electrophilic aromatic substitution, we are going to do bromination, nitration, sulfonation, these. Okay. Please write here, since the OH, that means the hydroxy group, is a plus M group, phenol gives ortho and para products, ortho and para products, and its reactivity is greater than benzene. So for both of them, the reason is what? The reason is same, plus M group, electron donating group. And it is also electron donating through resonance. That is why it is going to give you, ortho and para product. Now, first reaction that we are going to look in this case is bromination. Right, number A. Bromination. Now, in bromination, we use two different solvents. Okay, and it gives you two different products on different solvents because OH is so highly activating. Activating means its reactivity increases so much that in the presence of water, it gives tri-substituted product. So please see, we have OH. Now, we'll add Br2 because we are doing bromination. And then we are only going to change the solvent in these two cases. First of all, we are going to keep a non-polar solvent. Such as you can have carbon disulfide or carbon tetrachloride. Both of them are non-polar. In this case, you are going to get two different products, ortho product and a para product. The OH will be as it is. Br will attach on the ortho position, plus you will get phenol, which is having Br in the para position. Okay, Br in the para position. Now, another is a simple one, that is the usage of water. Okay, so if we are going to use polar solvent, for example, water, then in this case, we are going to get tri-substituted phenol. So there will be phenol, and Br will attach on all the ortho and para positions. Br and Br. Okay. Now, the compound here, it is known as O-bromophenol. And this is known as P-bromophenol. Okay. What about this one? This is known as 2,4,6. And you will be having tribrom. Now, why is this happening? Please write. is 2,4,6 tribromophenol. Now why it is happening? Please write here. In the presence of water, in the presence of water, phenol converts to phenoxide ion. Phenol converts to phenoxide ion, and the negative charge negative charge on oxygen atom activates the ring so much that the electron density at ortho and para positions becomes very high, and it gives tri-substituted product. After this, you will write nitration. No, Tarif, no, that is not picric acid. We are going to look at picric acid. When you add nitro group in all of these three positions, that is picric acid, okay, not bromine. Okay, so we are going to look at picric acid in this case only. Please write B part. That is nitration. Now, in nitration also, we are going to get two different types of product depending on the
Second is just
reagent. Actually, I have not written. Write this down. Depending on the substrate that we are using. Not substrate, rather the reagent that we are using. If you use dilute, we will get two products, ortho and para. And if we use concentrated, then I will get one product, that is tri-substituted. Let me know once you're done, guys.
Lens.
Can you scroll up to
Oh, you want to? Yeah, fine. More?
Yes, sir. Electrophilic aromatic substitution.
You have not written anything or what? Let me know once you're done. Done, guys? Yes or no? सबने लिख लिया?
Done, sir.
Okay. All right, next nitration. Please see here, and then after that you will write. Okay. So in nitration, we will take phenol. Now, in phenol, if I use concentrated H2NO3, I will get different product. If I use the dilute, then I will get different product. Okay, so maybe I can borrow something. Yeah. So phenol in the presence of concentrated HNO3, please write. I will get this phenol, which will be tri-substituted. That means you will be having NO2 in the ortho, in the para, as well as this ortho. But if I use dilute HNO3, then I will get two products. One is ortho substituted nitrophenol, and the other will be para substituted nitrophenol. Now, the name of this particular molecule is going to be 2,4,6. 2,4,6. This will be trinitrophenol, or its other name is picric acid. This is going to be O-nitrophenol, and this is going to be P-nitrophenol. All of you done? Yes or no, please tell me. Everyone done? I'm still writing.
Yes, sir.
Yes, sir.
Done now. Write some notes here. First of all, first point that you are going to write here is regarding the O-nitrophenol and P-nitrophenol. O-nitrophenol and P-nitrophenol, both of them, they have different boiling point, and that is why they can be separated via steam distillation. First point, you are going to write this only. O-nitrophenol and P-nitrophenol can be separated O-nitrophenol and P-nitrophenol can be separated using by steam distillation, as O-nitrophenol is more volatile. As O-nitrophenol is more volatile due to the absence of intermolecular hydrogen bond. O-nitrophenol is more volatile. That means that it is easily boiled. It can be boiled at lower temperature because it does not have intermolecular hydrogen bond. Now the issue is that O-nitrophenol, it has hydrogen bonding, but it is intramolecular. So what type of hydrogen bonding? Please see.
Sir, is it within the molecule?
Sorry. Within the molecule. So you're saying within. So OH is going to be like this. See, photo आ गया है क्या? फोटो आ गया, बेकार है लिए तो कोई काम कर लो, तुम्हारा डिलीट. This here guys, oxygen bonded to hydrogen. Now after that we will be having nitro group. Nitro group is nitrogen which is bonded to oxygen and doubly bonded to oxygen atom like this. Now obviously these two, oxygen and hydrogen, they are going to have a hydrogen bond. Now this is what a hydrogen bond between oxygen and hydrogen within a molecule, inside one molecule. Okay, within one molecule. This is known as intramolecular hydrogen bond. Intra hydrogen bond. Now similarly, if I have a p-nitrophenol, double bond O, and let us suppose you have hydrogen, double bond O and single bond O here, the OH atom, OH group is here, and let us suppose the hydrogen of the OH is here, then we have oxygen atom here, and the phenol atom is like this, phenol group is like this, and here you have NO2. Okay, so obviously these two are going to have intermolecular hydrogen bonding. Similarly, the OH of this nitrophenol and the nitro of other nitrophenol, other molecule, they are going to have hydrogen bonding. This nitro group will be having hydrogen bonding with another OH group. So all the molecules, molecule A, it is bonded. Molecule B, it is also bonded. Molecule C, it is also bonded. This is also bonded, right? All of them are having some type of force of attraction, which is making each and every molecule close together. And since they are having intramolecular hydrogen bonding, their boiling point will be higher. So what is this? Sorry, this is intermolecular, my bad. Because they're having intermolecular hydrogen bonding, their boiling point will be higher because the bond is between the molecules. And what happens when we try to evaporate? When we try to evaporate, the heat, it tries to break the force of attraction between two molecules. When we boil something down, then it is not going to affect anything inside a molecule. Whatever is inside a molecule, that will be inside a molecule only. Water, which is liquid, that is also H2O. Water, which is vapor, that is also H2O. Okay, but what is the difference? The two H2O molecules are far apart. So in the case of intramolecular hydrogen bonding, there will be no effect. It is not going to help in the boiling point also. So what we can write, O-nitrophenol can be easily boiled and p-nitrophenol will be not boiled easily. That is why in steam distillation, because of O-nitrophenol, because it is more volatile, it can be easily separated from the p-nitrophenol. All of you got this? Yes or no? Please tell me.
Yes, sir.
Both that. Okay. So, next point that you are going to write, this is regarding O-nitro and p-nitro. Another thing is modern method of preparation for picric acid. Is right, modern MOP of picric acid. Let me know if everyone is done. Anyone still writing? Anyone still writing? No, no.
Yes, sir.
Just writing. Please write it down quickly.
Yes, sir. Done.
So see, in modern MOP of picric acid, we start with phenol and then we do sulfonation. So for sulfonation, what do we require? We require concentrated H2SO4, and it is going to give you phenol as it is, and SO substituted on the ortho and the para position. Okay, you will get phenol, that is 2,4 disulfonic acid. Phenol 2,4 disulfonic acid. Now, when this is treated with concentrated HNO3, it gives you picric acid. Okay. You write the name of this particular molecule. This is phenol 2,4 disulfonylic acid. Sulfonic acid, not sulfonic, sulfonic acid. Sulfonic acid. Okay, so actually this reaction is not there in NCERT explicitly, rather it is in the texts. Okay, वैसे लिखा हुआ है. This is also important. If they ask a difficult question, they can ask from here, because it is not directly in the NCERT. They have written this reaction, and they have also like wrote it something like this. That nowadays picric acid is prepared as, and then I think they have also written, can you write the chemical reactions that are involved in this method of preparation? So these are the chemical reactions. Is everyone done? Yes or no? Please tell me. All of you done writing?
No, sir.
Write it down. So basically, if you are going to look at the electrophilic aromatic substitution of phenols, then you will see only two topics: nitration and halogenation. Okay, nitration and halogenation. Halogenation, that we are going to look at only at bromination. Okay, now, but they have also see inside the text also they have given you a reaction that is concentrated H2SO4. That is, sulfonation is also there, but it is not explicitly in the NCERT. Okay, so while you are revising, please make notes or make short notes using this notes. If you are going to use only NCERT, you will be missing some key points. Okay, NCERT से बाहर आ गया, NCERT से ज़्यादा hard आ गया सवाल, ठीक है, तो वो सब मत कीजिएगा, notes को पढ़िएगा. हाँ, NCERT से अगर आप notes बना रहे हैं, then make sure that you are reading each and every line of NCERT. You know, you don't miss anything. Done everyone? Yes or no? Please tell me.
Yes, sir.
Done, sir.
उसके बाद एक चलिए अच्छा सवाल है यहाँ पे. There is a good question in NCERT, and even though they have not asked this question till now, but I am seeing the level of CBSE board examination, it is going more towards like conceptual questions. So this is one of a conceptual question, and you are going to learn about a new concept in this question. So write the structures of major product expected from the following reactions. Now there is something that I am not sure is this part: mononitration of phenyl methanoate. This is the in-text question, not in-text. This is an example question, and they have also given the products. But the products they have given for phenyl ethanoate. Okay, so I think this methanoate is a printing mistake from NCERT, and it should be phenyl ethanoate. So one thing is that. Now we will leave that for now. We will look at these two problems: mononitration of 3-methyl phenol. Mononitration of 3-methyl phenol. So 3 is 1, 2, 3. This is CH3. Now, we have how many carbon atoms? We have 1, 2, 3, 4, and 5 carbon atoms, right? Now, if I look at OH and CH3, please listen to me very carefully. Don't write anything. If I look at OH and CH3, both of these are what? Plus M groups. Yes or no? Please tell me. OH is also plus M and CH3 is also plus M. Correct, guys? Ayana.
Yes,
Both
sir.
of them are plus M. No? Both of them are plus M. Now, I will talk about the reactive sites. I will talk about the reactive site. So, ortho and para will be reactive. Ortho and para will be reactive. So, let me do one thing. Red for this one and CH3 के लिए हम कर देते हैं green. ठीक है? If I talk about the second carbon atom, it is ortho to OH and it is ortho to CH3 also. Correct, guys? Yes or no? Please tell me. Bolo, Hayana.
Yes, sir.
Right. What about the third position? This third position, it is ortho to CH3 के लिए क्या है ये? CH3 के लिए ortho है, right? And what about OH? With respect to OH, this is para. ठीक है. What about the fourth carbon atom? With respect to CH3? With respect to CH3, it is what? Ortho, meta, or para?
Meta.
Meta. And with respect to OH, it is?
Meta.
Meta. And the fifth one, with respect to OH, it is ortho. And with respect to CH3, it is para. Correct? Now, so from these analysis, I can say that the fourth carbon atom will not be reactive. Yes or no? Because it is meta. And meta is in the meta position, electron density is not increased. Electron density is increased only in ortho and para position. Both OH and CH3, they are plus M. They are ortho para directing. That is why this meta position is not reactive for sure. All of you agree with me? Yes or no? Please tell me.
Yes, sir.
Okay, so I will remove this 1, 2, 3s and everything. Okay, so we have analyzed things right now, and we saw that what are the reactive sites here. The reactive sites are this position, and this position. Fine. Now I will number it once again: A, B, and C. But if you look closely in the A position, if you look closely to the A position, now this A position is very crowded. Can all of you see that? Yes or no? Please tell me. If I am doing nitration here, mononitration, then NO2 will be coming. NO2 positive should be able to, what should happen actually, please listen. Not NO2 is not going to come here. The electrons are going to, here we will be having more electron density, na, delta negative. So this position is going to attack on NO2. But I hope you can see that that is very less possible. The possibility of A position attacking on NO2 positive is very less. It is very less likely that this position is going to attack. And most of the reaction, it will occur from B and C position. And you will get very little, or we can say negligible amount of NO2 in the ortho position. Because the A position is crowded. Yes or no? Please tell me, guys. Is this clear?
Yes, sir.
Okay. So that is why even though A is having high electron density, it is having high electron density. If you attach a product there, but A cannot attack because of steric hindrance. So what I will write about A, I will write that cannot attack due to steric hindrance.
Sir,
Now,
steric hindrance means rotation of
crowdiness.
this bond.
No,
Okay.
not rotation of this bond. Crowdiness. Okay. So this H and this OH, all of these will be getting crowded here. That is okay. Now, when we have mononitration, I will use dilute HNO3, right? Dilute HNO3 because we are doing mononitration. And the product that we will be getting will be NO2 in B position and another product with NO2 in the C position. Correct, guys? OH as it is, CH3 as it is, NO2 in the para position plus OH as it is, CH3 as it is, and NO2 in the ortho position. Write this down. Phosphorate cannot attack due to steric hindrance. Then guys, yes or no, please tell me.
Yes, sir.
चल लिख रहे हैं, जल्दी लिखिए. जी हो गया. All of you done? Anyone still writing? Anyone still writing? Yes or no? Done, no? Please. Now, what is the reagent that we are going to use in dinitration? Tell me. If you want more than mononitration, then what do we use? Tell me, guys.
Concentrate.
Concentrated. We are going to use concentrated, and you are going to get only one product. In concentrated, you get only one product. Now, again, the same thing is happening. A, B, C, all are reactive. But what is going to give you the product? Only B and C. You will get NO2 on B and C carbons only. All of you got this? Yes or no, please tell me. Okay. Now, this was for A and B we have done. Okay. Now, let me take this question. Wrote the product, yes or no? All of you wrote this product, yes or no, please tell me. Anyone still writing?
Yes, sir.
No, no. See the C part here, mononitration of phenyl. This will be methanoate, okay? Not ethanoate. Sorry, not methanoate, it will be ethanoate. So phenyl ethanoate. How to make phenyl ethanoate? That is the first problem. So ethanoate, first of all, you make phenyl. And this phenyl will be acting as what? It will be acting as a substituent. So if it is acting as a substituent in ester, it will be attached on oxygen atom. This will be further attached with carbon and then CH3. So this is phenyl ethanoate. And here we are having carbon, which is CH3, right? So CH3 will be 1 carbon, 2 carbon, 3 carbons. Okay. Now, as you can see, now you can completely see that this position, and this position, all of these are reactive, A, B, and C. All of these position A, B, and C are reactive. A position, B position, and C position, all of these are reactive. But because you can see there is a steric hindrance in the A position, also this bond can be rotated, right? This bond is rotating, always it is rotating. And that is why this CH3, which is present in the neighborhood of A, it will be also in the vicinity of C once it is rotated. So both A and C cannot attack because of steric hindrance in this case. So if I do mononitration in this phenyl ethanoate, then I will be getting, first of all, it will be dilute HNO3 because we are using mononitration, and I will get single product only, that is NO2 in the para position like this, in the B position. Got it, guys? Yes, no, please tell me. A and C cannot attack due to steric hindrance. Is everyone done? Yes or no, please tell me.
So I'm ready.
Please write. After this, you can just write a point here, like a remark.
Yes.
Please write electrophilic aromatic substitution of phenol is faster than that of benzene. It's faster than that of benzene because the carbocation form is stabilized by electron donating group OH by plus M effect. After this, there are two important reactions, name reactions, Cole-base reaction and Reamer-Tiemann reaction. Okay, so please write number one, Cole-base reaction. ये आपका क्या हो जाएगा, कितना नंबर हो जाएगा? Wait a second, guys. Third था, I think. Yeah, fourth is Cole-base reaction.
Sir, EDG is electron donating group.
Yeah, correct. Cole-base reaction, ठीक है? Cole-base के लिए आप यहाँ ध्यान रखिएगा CO2, क्या ध्यान रखिएगा? Co and CO2, Co and CO2, Co and CO2, ठीक है? So first of all,
Can you scroll up?
you scroll up. Just
Done, sir.
so you start and you react this with NaOH to get sodium phenoxide. So what is sodium phenoxide? Instead of hydrogen, you will have ONA. Please don't write this, okay? Right now. And try to like expect what should be the product. NaOH डाला तो क्या होगा? You'll get ONA. NaOH is a base hydrogen. This hydrogen is acidic hydrogen, so this will be removed, and you will get a salt. OH यहाँ से निकलेगा, H यहाँ से water, and then there will be salt. So ONA. Now this sodium phenoxide is then treated with carbon dioxide. Here the main reaction is starting. CO2 at high temperature around 400 Kelvin and 4 to 7 atm pressure. Okay, now when this happens, then there is a formation of please see here, there's a formation of OH, and here you will get COONA. This is known as sodium salicylate. And on further acidification with dilute HCl, this COONA will be converted to COOH. Here you will have OH as it is, and here you will have COOH. Okay, so this is sodium salicylate. सारा लिख देते हैं, यहाँ पे लिख लीजिए इसको phenol. This will be sodium phenoxide. And this will be sodium salicylate, and this is salicylic acid. Salicylic Sally is SILI. Salicylic acid, no? Salicylic acid. Now, आपको अगर कूल फेज रिएक्शन लिखने आ जाए तो आपको ज्यादा कुछ नहीं करना है, आपको बस स्टार्ट करना है कहां से? फिनॉल से. तो स्टार्ट विथ phenol and two-step reaction you are going to do. No need to remember any 400 Kelvin, 4 to 7 atm. You don't need to remember anything. Rather, 2 or 3-step reaction. First of all, you are going to add NaOH. Second step में CO2. Third step में H+. That's it. You will get salicylic acid. This is pole-base reaction.
Sir, these are different steps.
No. I mean, both of them are same. I'm saying that you have to remember this. Okay. आपको याद ये करना है कि NaOH, CO2 फिर H. Pole-based reaction. Main important part here is CO2. Okay. Main important part is CO2. Now, statement of pole-based reaction can start either with phenol. You can say when phenol is reacted with sodium hydroxide, it gives sodium phenoxide, which is then treated with carbon dioxide at 400 Kelvin temperature and 4 to 7 atm pressure, which further forms sodium salicylate. And on further hydrolysis or on further acidification with dilute HCl, we get salicylic acid. Okay. You can write this. If they ask you coal-based reaction, then you can write this reaction also. Okay, no need to write the statements. Okay, at least in the boards, you don't need to write the statements. I have seen the mark schemes and everything. You don't need to write the statements. You just need to write the reaction. Okay, अगर coal-based पूछा है तो CBSE accepts both the things, either the statement or the reaction. I think I have some Let me see. This Colby's or Reamer team in both. I think both or some one of them was asked. Let me see. What was that? Hmm. $24. This is 5622. Second set, second paper. Second set, second paper. 622. 24. Okay, so in the mark scheme, it is given like this. No need to write the statements or anything. है ना? देखिए पहले NaOH, first is NaOH, then CO2, and then H percent you have to write. That's it. ठीक है. If you want to write it exactly like this, ये भी आप लिख सकते हैं. ठीक है. But both of these are going to give you marks, complete marks. Okay. After this, you are going to write Reamer-Tiemann reaction. Have we done preparation of aspirin? Tell me, guys, did we do preparation of aspirin? I think we have done now. When we reacted with acetylation, when we did, preparation of aspirin is done, right? So this is salicylic acid, salicylic acid plus acid anhydride, you will get aspirin. ठीक है, तो ये salicylic acid वहीं से आया, from Colby's reaction. Okay, after this, you are going to write which reaction? The fifth reaction. That is Reamer-Tiemann reaction. Reamer-Tiemann reaction. In this reaction, we use, please write here. We use phenol, and in the presence of chloroform and NaOH, first step, we are using NaOH and CHCl3 chloroform. The second step, you add water, you will get salicylaldehyde. Okay, so the exact mechanism for this reaction is a bit complex, but so थोड़ा सा आसान करके आपको बता सकते हैं. because most of the reaction that is happening here, that is completely inside your syllabus. Okay, but in the case of salicylic acid, it was not like that. So I did not give you the complete mechanism. In the complete mechanism, you can see we have starting with phenol, and you have NaOH, right? Phenol and NaOH. So it is going to get converted to ONA. So obviously, I can start with sodium phenoxide, and then we are treating this with CHCl3. Now CHCl3, it reacts with NaOH and it forms carbene, and there is a carbene mechanism that you can that we don't need that carbene mechanism. What you can understand from here is, please see, this is the ortho position, right? And if you have done Friedel-Crafts alkylation, then in Friedel-Crafts alkylation, what happens? One chlorine is removed, and then it is directly attached with that on the ortho position. You have RCl, Cl is removed, and R is attached on the ortho position. So same thing you are going to do. You are going to write the ONA as it is. And here we are going to attach carbon with one hydrogen and two chlorines. One hydrogen and two chlorines. After this, in the presence of NaOH, NaOH is still there, so it will react with what? See, you have done this reaction, RCl plus NaOH will give you what? It will give you ROH. So here we have carbon atom and chlorine. So this chlorine will be replaced by OH and OH. You have two chlorines, so both of the chlorines will be replaced by OH and OH. So you have ONA as it is. And now you will be having carbon with one hydrogen. Here you will have OH, and here also you will have OH. Now, in the first class itself, we saw that when we have gem diol, that means the carbon atom, one carbon atom, it is having two OH groups, then it is not stable, and water is removed. So you will remove water like this, right? There is a rearrangement which goes on. Water is removed, and you will get the ONA will be as it is, and here carbon with hydrogen as it is, and double bond O. If you look at the previous class, I mean the first class, then you will see that if we have two OH and one hydrogen, it gets converted to aldehyde. The same thing is happening here. And on further hydrolysis in the presence of H+, I will get the OH of phenol back, and this will be CH. Okay. Will you write this down? Let me know once you're done. After this, you'll write a question. Phenols don't show. Friedel-Crafts reaction. ना ये alkylation show करता, नहीं. It does not show alkylation, neither it shows acylation. The phenols do not show Friedel-Crafts reactions. Why? Write the answer. The lone pair of oxygen atom in phenol, the lone pair of oxygen atom in phenol, you can write bonds with the Lewis acid used in Friedel-Crafts reaction. ठीक है?
Sir, what is FC?
Friedel-Crafts, yeah. So we have two different Friedel-Crafts reactions now. That is Friedel-Crafts alkylation and Friedel-Crafts acylation. So both of them does not happen, and both of them it requires a Lewis acid. So the what Lewis acid इसका काम होता है ना, वो काम नहीं करता. Lewis acid it attaches on the oxygen atom. It has to attach on the reagent, but it attaches on the oxygen atom of phenol. So that is why we cannot do Friedel-Crafts reaction. Similar question is there also in the case of aniline that we are going to look at in the last chapter, that is amines. So aniline they also do not show because aniline के NH2 में नाइट्रोजन में भी लोन पेयर होता है. ठीक है. सबका हो गया? After this, you will write the topic. See, phenol is also completed. You will write the topic ethers. And in ethers, we will just look at a few nomenclatures and then we will done with ethers for today. We will start with MOP of ethers in the next class. Okay. So after MOP, one class on, yeah, tell me.
The question phenols don't show which reaction?
Friedel-Crafts.
Okay.
FC is Friedel-Crafts. लिख ही देते क्या हम? लिख ही देना चाहिए था हमको. FC क्या है? Friedel-Crafts. Friedel-Crafts जो है ना, दो साइंटिस्ट का नाम है. फ्रीडल का नाम है, दूसरा क्राफ्ट्स है. तो दोनों में कैपिटल होता है जनरली. कभी-कभी हम भी इसको C छोटा लिख देते हैं. ठीक है. Now in ethers we'll look at a bit of nomenclature. So see, IUPAC nomenclature, all of you must know this. For example, if I have CH3 bonded to oxygen, further bonded to CH2 and then CH3, then this is larger and this is smaller. Okay, so the smaller one will get methoxy, and the alkyl group with more carbon atom, it will get the alkane part. Okay, so this is ethane, this is methoxy. So the IUPAC nomenclature will be methoxyethane. Methoxyethane. This is IUPAC nomenclature. But when I come to common name, then you just need to look at the substituent. So this is what substituent? This is ethyl. And this is what substituent? This is methyl. Okay, so you will write both the substituent, so methoxyethane, or we can also write ethyl will come first because of alphabetical order. Ethyl, methyl, ether. This is when you are having different alkyl groups. But let us suppose if I have something like this, 2 carbon atom oxygen, 2 carbon atom, and then oxygen. Okay, so here also we are having ethyl. Here also we are having ethyl. So in this case, I will write the name as diethyl ether. And similarly, if I have this will be dimethyl ether. Dimethyl ether. ठीक है. एक होता है डाई टर्ट ब्यूटाइल ether. Di tert butyl ether. So what is tert butyl? Carbon with 3 CH3 groups. And this carbon, this CH3, here also CH3, and here also CH3. And this carbon atom is the point of attachment to oxygen atom. Further, it is attached to the same thing: carbon, CH3, CH3, and CH3. Ditert butyl ether. Write this down. So these common names are also very important. Okay, so it is important because you are going to get the questions, and the questions will be using these common names only. ठीक है, तो आपको पता होना चाहिए if they are saying ditert butyl ethyl, ditert butyl ether, तो क्या है? Is Rava saying something?
Yes, sir, can you scroll up the question and answer? Just the answers last line.
Yeah, fine, no problem. FC is equal to Friedel-Crafts. जी, all of you done? Yes or no? Please tell me. Anyone still writing? Not done.
Yes, sir.
Right. Tell me, anyone, is there anyone who has made the sheets for haloalkane and haloarine? कोई भी है जिसने बनाया हो haloalkane haloarine का sheets? कोई नहीं ना? बनाइए भाई, बनाइए, एंड में बहुत काम आने वाला है।
I'm in the last.
अच्छा, आप लास्ट में बना, आपने मेथड ऑफ प्रिपरेशन बना लिया?
Yes, yes.
Send it to me, okay? Whatever you have done, na, please send it to me.
Yes.
Yeah. Still, anyone writing? तुमने लिख लिया, हाँ या ना?